Formal charges. All right. So calculate the formal charges on the atoms shown in red. All right, so we have this molecule here, CH3, 2, and I'll just put both of them here on this oxygen, CH3, and there's OB, and it helps to draw out the entire molecule. And I'll show you why, because, and we have this lone pair on oxygen, so the formal charges on oxygen and boron in this molecule. So formal charge equals the number of valence electrons minus the number of electrons the atom owns. And to figure out how many electrons the atom owns, that is the lone pair electrons plus half of the bonding electrons. And so here, if you want to look at this oxygen in this molecule, the oxygen has 6 valence electrons, so that's the number of valence electrons here. The number of valence electrons is defined by the periodic table. So this is for oxygen, it's always 6. And then the number of atoms and the number of electrons the atom owns is determined by the specifics of the bonding in the molecule. And so we count the lone pair, 1, 2, and then half of the bonding electrons. So there's 1 in this bond, 1 in this bond, and 1 in this bond. So 1, 2, 3, 4, 5. So 6 minus 5 equals 1. So this oxygen has a +1 formal charge. You can write it with a plus in a circle, or you can also just put a little plus there to indicate the oxygen has a plus formal charge. So boron, if we go to boron here, boron has 3 valence electrons because of its place in the periodic table. And let me just use the same color here, 3 valence electrons. And then how many electrons does it own here? Well, it's half of the electrons in these bonds, so 1, 2, 3, and 4. So 3 minus 4 is -1. So boron has a -1 formal charge in this molecule. So let's look at, so this was A. Let's look at B here. So H2C, and I'll draw out, again, it helps to write out all of the bonds so you can tell easily how many bonds there are when you're counting the number of electrons an atom owns. So in this case, let's just look at this. We're looking at these 3 atoms, the carbon and the 2 nitrogens here. So carbon has 4 valence electrons, and let's see, how many does it own? 1, 2, owns both of these in this lone pair, and then 3, 4, 5, 1 for each of these bonds. So 1, 2, 3, 4, 5 is -1. So carbon here has a minus formal charge. Sometimes we circle those just to make it clear. So let's look at the nitrogen here. And this nitrogen, so nitrogen has 5 valence electrons, so 5 minus 1, 2, 3, 4 from each of these bonds. It owns 1 electron, so 5 minus 4 is +1. So this one, nitrogen has a plus formal charge here. And then let's look at this one. So 5 valence electrons for nitrogen minus 1, 2, both lone pairs, and then 3, 4, and 5 from these bonds. So 5 minus 5 is 0, so that has no formal charge, and we don't indicate that with a sign. It's just, it doesn't get a sign indicating neutral formal charge. So this is diazomethane, and this is the correct way to write this Lewis structure. If you were going to write anytime you were to write a structure of diazomethane, no matter what, you always have to put the formal charges in, even if you don't write out every bond, you would be indicating the molecule like this. And that is a correct structure for diazomethane. Formal charge always has to be in the Lewis structure.